Question 3. At a fairground, Kirsty throws N balls in order to try and knock coconuts off their stands. Any coconuts she knocks off are replaced before she throws again. Kirsty counts the number of coconuts she successfully knocks off their stands. On average, she knocks off a coconut with 20% of her throws. Part A, what assumptions are needed in order to model this situation with a binomial distribution? Explain whether these assumptions are reasonable. Okay, so thinking back to last year, for binomial, our binomial situation has a number of trials. Well, we've got N balls, but that's not an assumption. We're told that there are N trials. We have a success or a failure outcome. Okay, well, we know that. Okay, is she hits the coconut or she doesn't. Again, that's not one of our assumptions. Okay, so the next thing about binomial is that the probability of success is fixed. Well, it says on average she knocks a coconut with 20% of her throws, but I think we can write that as one of our assumptions, that this probability is the same for every single throw. It's not just averaging out at 20%, okay, because that would be slightly different, wouldn't it? So let's say one assumption is that the probability of success on each throw is fixed at 0.2. Okay, so we're assuming that's what this last sentence means. Okay, is that reasonable? Now this is where you might decide yes or you might decide no. Okay, we'll come back to that once we've said our other assumption, because they're basically kind of linked anyway, our reasons. So the second assumption we can write down, because it does say plural, doesn't it? So we've got to think of a second one. The other one for binomial is that the successes and failures are occurring independently. Okay, so you don't end up being, more likely to have a success if you just have a success, so you 2 on the trot sort of thing. So basically we're talking about independence of the successes and failures happening. So it's not sort of like Poisson where we would say the events occurring independently and randomly. With binomial we say they're independent from throw to throw and the probability is fixed. Those are the 2 things for binomial we will need to think about. So we're assuming that the success or failure of each throw is independent. And if I put brackets, I can put compared to the previous attempt. So, are these reasonable assumptions? Okay, so you could say yes, because this is how good she is. Maybe the target's a long way away. She's not really getting better or worse every time she throws. Okay, so you could say these are totally valid assumptions. Okay. So you could say, yes, they're reasonable as she's unable to improve on a 20% success rate. Subsequent throws have no greater chance of success. Okay, maybe the target's a long way away or something like that. Or you could say, no, it's not particularly reasonable. So you might say that you think she would get better at throwing, possibly. Okay. So if she's practicing and she's having quite a few throws, her aim might get better. She might be able to sort of slightly replicate what she did. So maybe it's not independent. She might get more accurate with her throwing, get her length right. So the probability might not stay at 0.2. Okay. You could even argue that she might get tired and get bored of it. So, her accuracy decreases. So there's lots of things you can say that will get this mark. You just have to think of a reasonable reason why that, thing you've written would make possible sense. So I might say, no, it's not reasonable. She might improve her accuracy. She might be able to replicate a successful throw. Okay, so there's things that you can think of for either way, but you need to think of a reason or two.